Hello, good morning, good afternoon, good evening, whatever time zone you are. Welcome to another episode of the Bay Area Apache Spark Meetup. My name is Jules Damji. I am the developer advocate as part of the Databricks developer relations team, concentrating and focusing on open source. Today, I'm joined by my esteemed guest, Scott Van Wandenberg. He's a staff product manager for PySpark and all things Spark. Say hello, Scott.
Hi, everybody. Welcome. Glad to have you. Thanks for joining.
Thank you. And joining me is our main speaker today, Daniel Tenedario. He is the senior staff software engineer with the Spark team, handling all aspects of open source Spark with Databricks. Hello, Daniel. Thanks for joining us. I think you're mute.
Hi, thanks for having me.
You're welcome, anytime. And then in the background, we actually have Carly, our program manager, who's making all things very possible. We're coming to you live streaming from LinkedIn and YouTube as well. So if you want to rewatch this particular later, go to the YouTube channel. The chat is the URL is in the chat. You can actually subscribe to that particular channel and reshare with others. So keep your questions coming in the chat. We will try to answer all those questions possible, not all of them, given the time constraints that we have. But those that we can't get to, we'll follow up after the session is over, since they're going to be live and available to us on LinkedIn and YouTube. Now, keep them coming, so we try to address them at the end. Now, just a couple of private thoughts of you. Apache Spark has come a long way, from the early days, and it never really ceased to amaze me how innovative and how enduring the Spark community has been for all these particular years, almost a decade. And I have to thank the Spark community, the contributors, the PMC members, and the committers for having come along with this journey a long way. And I want to thank them from the bottom of my heart for bringing what Spark is today. We have come a long way from Spark 1.0 to Spark 4.0. In 1.0, we sort of introduced the first, when I talk about we, I'm talking about the community and the committers and the PMC members in general. We introduced a novel idea of computing, in-memory computing model, which with the traditional MapReduce. We moved on to Spark 2.x, where we actually introduced structures and data frame API, which was more of a declarative API as an alternative to RDDs. And then in 3.0, we introduced the adaptive query execution with data pruning on the fly, and also extended our ability to accelerate GPUs, further extending the Apache Spark workloads. And now we are at actually a milestone in 4.0, which is packed with a lot of features. And there is no way we can cover everything today. We'll try to concentrate on some of the things that Daniel is familiar with, but subsequently we'll be having an hourly meetups. Starting in 2 weeks from now, we'll be talking about structured streaming, and then we'll keep on concentrating on each and every feature. So stay tuned for us. And with all that said, I'm going to hand it over to Daniel, who's going to sort of give us an overview of what's actually coming in upcoming 4.0 and more to come in subsequent meetups. So Daniel, take it away.
Very good. Thanks, Jules, for the introduction. So my name's Daniel Tenedario. I've worked on Apache Spark for a little over 3 years, from Databricks, and carrying forward a bunch of experience from working on SQL engines in the past. And it's been a lot of fun so far. I'm working on Spark with you guys and with the community. And I'm super privileged and happy to get the chance to kind of discuss with you guys some of the awesome new stuff that's in Spark 4.0. As we kind of covered a little bit so far, Spark 2 and Spark 3 brought some kind of groundbreaking new functionalities, AQE, other awesome new stuff. I like to think Spark 4 has a lot of new features that are going to make it pretty interesting and exciting to define pipelines and express logic. So let's get into it. Cool. So so the agenda for this particular talk, we'll go over some new functionalities to start with that are available in Spark 4, and then we'll jump into extensions and some powerful new things that are available for the platform, and then switch to custom functions and procedures after that, and then end up with usability and some new features that are available there, right? And so, as Jules mentioned, this is just a subset of the awesome set of features available in Spark 4. we thought it would be interesting to kind of group them together in this way, to kind of show you guys some of the new things you can use in the platform. Yeah, so let's get started. Right, so the first big kind of major feature platform in Spark 4.0 is Spark Connect. So I'll go over it briefly here. Right, so a lot of you have probably heard something about Spark Connect before. So it's reached kind of a maturity level now where it's recommended for new Spark programs. Right, so to go over kind of the motivation, why do we care? Why is this important? Right, so as a bit of history, up until Spark 3.4, the way to run Spark programs has been to express a program in Scala or Python, right? Import Apache Spark as a library, and then run the program. And when the program wants to issue queries or commands with data frames or SQL, it will dispatch stages to the pool of executors in a distributed cluster, right? But the important point is that the program running the initial Scala or Python becomes the Spark driver, right? So it becomes the driver, it does the query planning, etc. Right? And so it's kind of integrated together with all of the imports that process is performing in the Scala or Python to bring in libraries that it needs, right? So it comes in with support for Scala, Python, and Go. And so that's kind of how it's been so far. Right. So what is Spark Connect? So Spark Connect is a client API that kind of adds a layer of separation between the client part with the programs and then the Spark cluster. Why is this a big deal? Right. So it's a big deal because it lets the programs run somewhere else besides where the Spark driver sits in the cluster. And specifically, that means it's now possible to have these programs written in Spark Connect kind of protocol. And then the Spark cluster, it's actually possible to upgrade it independently of the programs, right? So if anyone's ever been through a Spark upgrade before, a version upgrade before, there's a lot of dependencies. It can take a lot of work. It's tied to the program. So if the programs are using specific features of the client APIs available in specific versions and they have to be updated, right? That can be a bit of work. But with Spark Connect, if your programs are written in this protocol, they can just run anywhere and then send the data frames and SQL commands over to the Spark cluster running somewhere else, right? So this makes it possible to do lots of awesome stuff. For example, writing connectors and SDKs in many languages, right? So you can build support in a different language, and then as long as it serializes the protocol, it can work with Spark, right? So Scala and Python are not the only options anymore. It's also possible to install it pretty easily, right? So you can install Spark Connect with this simple pip install command. It's just Python. If you want to get started, it's only 1.5 megabytes. You don't have to pull in PySpark itself, which is over 350 megabytes to use. You can just install this, try it out, and it's a lot easier, right? So the thinking and the hope is that if folks write their programs, the Spark programs with Spark Connect API, then everything just becomes easier, right? It becomes easier in the future to move them to new Spark clusters or kind of start using new clients. You can onboard new clients and just pip install the simple package and just send it to the cluster elsewhere, right? So it's kind of a big sea change for Apache Spark. Cool. Okay, so we talked about Spark Connect. Let's go into some features. So this is some fun stuff here. So let's talk about ANSI mode, right? What is ANSI mode? So with the SQL queries and the SQL dialect, there's kind of two ways that Spark supports writing SQL, right? There's like kind of the legacy Hive syntax that supported until recently. And then there's ANSI mode, which is essentially adhering to the SQL standard, right? So SQL standard, if you write SQL queries elsewhere in another engine or another project, and they adhere to the standard, coming to Spark will be very easy because the behavior will be the same, as close as possible. That's what standards kind of are for, right? So ANSI SQL mode is on by default in Spark 4.0, right? So this is the behavior you'll get by default. And it'll give benefits like throwing descriptive error messages if there's invalid numerical operations like division by 0 or invalid casting. May have returned null, the legacy kind of Hive SQL semantics before this. But with ANSI mode, you'll get descriptive error messages saying, this is invalid. I'm not going to give you correct data, right? I'm going to tell you that you should fix it, right? And it'll force you to kind of keep your data quality high, right? So without ANSI mode, this is kind of what it might look like, right? You'd perform division by a column, and if it's 0, you just get a null. Pipeline runs, you may not even know, right? On the other hand, with ANSI mode, you get an error message, and it actually gives you the call site, and actually gives you the line number. This is kind of what it looks like with a Databricks notebook with a Spark 3.5 with ANSI mode turned on. And then with Spark 4.0, more recently, it's even cleaner. You get the exact expression highlighted, and then you get a kind of a clear error message saying, here's the error code, divide by 0, division by 0, here's where it happened, and here's a suggestion you can do to run your query or command again, right? In this case, you can use the try divide function to explicitly opt in to this null behavior if you want null in the case of division by 0, which in some cases is okay, but in the cases that it's not okay, you'd rather not have corruption, right, in your data. So that's just one example of how ANSI mode works. Cool, and that's on by default in Spark 4. And so that call site highlighting is also available with data frames, right? So it kind of gives you the line number and the operation that triggered the error, right? So that's kind of what's implemented so far. PySpark support is under development. Spark Connect support is under development as well. And so is native notebook integration as well. So this is an important feature for Spark to make SQL, as the number of SQL queries grows larger for users, it helps bring consistency and understanding and kind of clarity of the data to all the users. Cool. Okay, moving on. Let's talk about the variant data type. So for semi-structured data, this is something new, right? What does this mean? So let's talk about JSON scanning, ingesting JSON objects, right? So the JSON is a supported data source in Apache Spark. What if you could ingest it and it could be fast and also like kind of flexible, because as we know, JSON has no canonical schema. The records can just have whatever fields they want. You might have a data source for all the series of JSON records that happen to have the same schema, but it's not guaranteed. That's kind of a challenge. So how can we make this work? Right. So with a variant data type, the idea is you can use this parse JSON function over a JSON string, and it gives you a value of type variant, right? And what this means is you can insert this into storage, query it back later. And when you query it back later, the SQL analyzer knows this is a value of type variant. And that means it's JSON records that have been ingested that have variable schema. And you can use this functionality to query fields out, right, as shown here, right? So this is kind of what it looks like. And so why is this a big deal, right? So you could imagine trying to process this with just string manipulation, right? Like you could imagine JSON records as strings, and you query them from a data source, and then like have some function to extract a field out, do whatever you want, right? So the variant data type is important because, in contrast to string manipulations, is because there's actually a different storage representation, and the query execution is optimized for this, right? So it's something 8 times faster to use this variant data type than just chopping up strings, right? So it's also really easy to use. So go check out variant if you use a lot of JSON. It's really useful. Cool. Okay, next feature, big feature that's new, is called string collation, right? So what is this and why is it helpful, right? So string collation in SQL defines a way to compare values against each other in ordering or grouping operations. And so the idea is you can associate a collation with a column or value, set of values, and that lets you decide if the comparisons are case sensitive, case insensitive, locale aware, how accents behave, stuff like that, right? So this is supported by built-in string functions like lower and uppercase, substring, etc. But kind of more importantly, group by and order by clauses will respect this behavior. And this is integrated from Apache Spark all the way through Delta Lake and Databricks Photon. It's like integrated all the way through. So it'll just work, right? So let's take a look at how this represents. Like, so what's the default behavior? If you do an order by from some strings, this is what you get. Capital A is less than capital Z, which is less than lowercase a, less than lowercase z, all of which is less than accented characters. So this is kind of the sorting you get. And this might not be what you want, right? So let's look at how we can control it, right? So you can apply collation on the ordering operation, and you can use Unicode, and now you get kind of something more like what you'd expect, right? You get the accented A appears next to the non-accented A. Lowercase and uppercase kind of appear together rather than separate, right? And so and then you could consider Unicode CI, which makes it case insensitive, which is just something that you often want. Some legacy on-premise says SQL databases have case insensitive behavior. So if you're trying to move off those into the cloud or onto open source projects, then you can use this to kind of just make the behavior the same without going non-standard, right? So you're keeping it SQL standard, and you can kind of pick what you want on a kind of operation by operation basis. Like on a query by query basis, you can kind of pick, right? And so by the same token, you can extend the collation to say Unicode CI AI, which now means that the accent behavior is now included, right? So you can say where it starts with the string name with this collation starting with A, and you'll now get the accented letter A kind of appearing in the result, right? So it gives you a lot of flexibility. And so with collation, it means you can use Spark in many different parts of the world, and it'll behave like what you'd expect in different regions and locales, so making Spark more useful to many people across the world. So we appreciate everyone using Spark and contributing to it and everywhere that they come from. Cool. So let's move on to the second section, right? So let's talk about Python. And more specifically, let's talk about Python UDFs and what you can do with them. Cool. Okay, so Python UDFs, as a reminder, let you define custom functions in your PySpark program to integrate into the query, right? So you can run a SQL query or data frame query, but you can also just define some functions in that program to say, like, I want to run this in my SQL and just like bind it in. It's pretty easy to do with PySpark, and it makes it flexible, right? If there's something you want to apply on a value by value basis that's not built into the engine, you can kind of use the UDF for that. And yeah, so we'd like to introduce Apache Arrow, which is a protocol that we can use for deserialization. So this kind of improves the performance of Python UDFs, kind of standardizes the type coercion, right? So since Spark 3.5 and now it's 4.0, you can use Apache Arrow optimization for function by function basis. right? With this use arrow is equal true. Or you can just turn it on for the whole session, the whole Spark session, right? The spark.conf.set. Set the config. Now all your UDFs in the session will use this optimization. You don't have to think about it. Right, so for performance speedups, we see something starting from 1.5x faster and going up from there, right? And then when you chain functions together, the benefits also accrue even more, right? Because they can chain together, right? So the Apache Arrow data can stream from one UDF evaluation to the next, and you can take advantage of that without serializing, deserializing back and forth unnecessary times, right? So they can get even better speedups, 2x and faster from that. And it's really easy to turn on. It's just a config, right? So that's pretty cool. Right, so this is another example. And there's a link in here that you can look at an open notebook and kind of check out the difference. Cool. Okay, so that's a Python UDFs. Scalar UDFs in Python have been around PySpark for a while. Let's jump into a feature that's completely new, Python data sources. So this is awesome, right? So why is this awesome? Well, I think Python data sources is kind of self-explanatory name, right? You can write new data sources for your Spark program in Python. Why is this awesome? People love Python. Python is awesome. That's reason one. Pip install is easy. And it's also a lot simpler of an API to set this up than DataSource v2, which you can use with Scala, right? As an open source project, you can download Spark and then just add data sources or just extend the code as you want to, right? So you can do that in Scala. But there's a lot of kind of knobs and moving parts associated with adding a Scala data source, kind of the way that Spark's built-in data sources work. In contrast to that, the Python data source API is much, much simpler and easier, right? To keep on to the Pythonic principles, right? So yeah, this was introduced in SPIP and went through. So it's available in Spark 4.0 preview and a Databricks runtime since 15.2. And it supports batch and streaming operations and reads and writes. Right? So this is kind of a sneak preview of the API. There's this base class that you can inherit from. Right. So what are the 3 steps? That's pretty straightforward, right? You can create a data source. So you can create your class to inherit from the abstract base class data source. That's step 1. And then fill it in, right? Fill in its methods. Step 2 is register it. Spark.datasource.register. It's kind of very similar to registering a UDF. You can just register the data source, and now it's available in the session, right? So step 3, you could just write spark.read.format name of my data source, and then go for it. Or you can write data to it. You can say df.write.format my data source and write to it. So that's the basic way to use it. Cool. So there's a lot more to Python data sources as well. There's some other functionalities, but there's a lot of features to cover. So yeah, let's move on to other exciting stuff. Cool. So the next big feature, Python UDTFs, which stands for user-defined table functions. Right. So idea behind this feature is we can consider PySpark scalar UDFs that have been around for a while, where each such scalar UDF will accept 0 or more arguments from one row of data and then return one scalar result. For example, it could consume 3 integers and return a string and run once per row. In contrast, in comparison to that, Python UDTFs, or user-defined table functions, each one of these appears in like the from clause of a SQL query and returns an entire table, right? So you register it, you put it in the from clause of a table as a table, and then select from it as you want, right? So this is kind of like what the API looks like. right? So you have, you import the UDTF symbol, and then you can define a class. And the essential idea is this eval method accepts the arguments, start and integers, for example, in this particular example, and then it runs, and then it yields one or more rows using just the Python yield functionality, right? So this is kind of like the basic idea. So that's how you define one, and then to query it in SQL, for example, you can, in the from clause, you can put UDTF followed by parentheses, and then put your arguments that you want to provide, which can be 0, right? So you can just have 2 parentheses and that's it. Or you can have your arguments. In this example, we're using SQL named arguments, start and end with arrows. So this is in the SQL standard. So this works. You can provide them out of order, you can apply defaults, right? And then you select the values out. Or with data frames, you can evaluate it like this, right? You pass the values in as literals, and then you get a data frame, right? So you call .show on that, kind of get the same result. Cool. So that's the basics. There's a lot of kind of more powerful features for this. So to kind of make them more useful than just like specific canned scenarios like that. One of the biggest ones is called polymorphic analysis. What this means is, in contrast to the previous UDTF, here we define the output schema of the UDTF statically, right? There's 2 columns, they're both integers. That's the output table. But it's also possible to dynamically generate the output table schema based on the values of the provided input arguments. So it can return a different schema every time you call the function. That schema is fixed for the query that called it in that call site. But from query to query, or from call site to call site in the same query, it can change. It can be different, right? So for this example, we define this analyze method that takes an argument, in this case, a file name string. We open the file, look at the contents, and then determine the schema of the output table depending on the string, depending on the file contents. Right, so you could call it like this. Call my UDTF, pass in the config file name. It opens it, looks at what's inside, and gives you a table that's different depending on what file you told it to read. Cool. So in addition to kind of dynamic output schemas, it's also possible, we covered passing scalar values to these UDTF calls. It's also possible to pass tables as input, right? So you could pass a table as input, and the UDTF can read its rows of the input table, do what it wants, and then yield output rows. So it can have a UDTF that takes an input table, produces a different output table, right? So, and when you do that, you can define how the rows of the input table are partitioned across different calls of the UDTF, right? So here's kind of an example of what that looks like in a SQL call, right? So let's say you want to call this UDTF count and max. And we'll pass in an input table named T as the input argument. And we'll also define the partitioning. So we can say partition by expression. And what this means is all the rows of the input table with the same unique combination of values of this partitioning expression set will get consumed by one call of the UDTF. So for this example, all the rows of the input table T, where ID divided by 10 is evaluates to the same number, will go into the same instance of this UDTF. So the init method will run, eval will run once for every row of the input table. It can keep state in the class, and this terminate method will run at the end after it's done. So you can kind of know when the partition is over. Cool. Yeah, so in concert with these features, you can use variable arguments, keyword or positional arguments with Python UDTFs, right? So you can just use star args or star kw args in Python for the analyze or eval methods. And if you do so, it will support dynamic arguments, and you can just pass in what you want. And just unpack the arguments like regular Python does, right? And so to pass them in SQL, you can use SQL named arguments, right, as we've shown. And it can just dynamically look at them and decide what to do, right? So for this example, we pass in two SQL named arguments A and B, and it'll create a column in the output table for every such column, or a such argument that we passed in. And finally, when you do all this stuff, if you want to define polymorphic analysis and do more powerful work in the UDTF analysis based on the input arguments, you can actually return a custom object and from the analyze method, which runs once. Analyze method runs once per call in the beginning. And this subclass, it will be passed automatically to every subsequent init method, right? So if you do expensive stuff, like opening files, reading from cloud object storage, whatever, you don't have to repeat that for every partition of the input table, right? You can just do it once and then it'll be propagated out. And you can structure it in a class for convenience, right? This is kind of an example of what that looks like, right? You have the analyze method, gets an input argument, looks at it to make decisions, returns a schema, and then also fills in some other fields of the class that we want to propagate out. Cool. Okay, so those are extensions. Now let's get on to some new kind of custom functions and procedures that are available. Spark 4.0 is pretty exciting stuff as well. Cool. So yeah, the first one is SQL pipe syntax. Yeah, this one I was involved with personally, so I'm kind of excited about it. It's very Spark, very data frame kind of integrated kind of idea, right? So what's the idea, right? And this is inspired by a research paper from Google and VLDB last year, right? In which was very well received. And so what's the idea, right? So the idea is that how do data frames work? Well, data frames, as we know, let you specify and express your logic starting with a table reference, like a CSV files or JSON file set or whatever. And that's a relation, that's a data frame. And then you can chain operations on the end. So you can say .filter, .group by. And it kind of reads from start to finish in a sequence, right? You start with a table and then you do stuff. And once you do that for a little bit, it's really easy to understand. And it reads in order, right? And also it abstracts well in your mind because you look at any one of these steps and it's kind of orthogonal to where it appears, right? A dot filter will filter for the preceding relation, and that does the same thing no matter where the dot filter comes from, right? So it's like kind of abstract it nicely. Here's an example of data frames. We all know them, right? Spark.read.option CSV. So you read a CSV file and then do stuff. Cool. So yeah, welcome to SQL pipe syntax. This is now available in Spark 4.0. You can do the same kind of idea in SQL now. So you can start with a table reference with from T or table T, and you can now pipe operations to the end of it in a sequence, just kind of like data frames, right? So you can say pipe where clause, pipe select. So let's look at kind of what does this look like, right? So here's TPCH query 13 as an example. Yeah, so you have an inner subquery from the customer table. Let's do a left join, group by, aggregation, and that's the inner table subquery. And then you do another aggregation and grouping and ordering on the result, right? And then you do a count of that. This is what the SQL looks like. This is ANSI SQL. So when you convert that to SQL pipe syntax, it comes out of this nested structure into something that looks more like data frames, right? You save table name, customer, from customer. This part defines a table. This part alone, if you can just run from customer and it'll run and give you the table, right? And then you can say pipe left join, which means I'm now doing a left join. Pipe aggregate, so you perform an aggregation on the result of the join, and so on, right? So we've taken the nesting out and taken a lot of the complexity out. And you can look at any of these steps and it's just aggregate the previous result. And that's all you have to understand. Cool. So let's get more crazy with it, right? Let's look at this example with more subqueries in it. And we have some nesting here. Right. So this is TPCH. These are kind of very standard queries. It's kind of complicated, but this is how it works. Yeah, so let's convert that to pipe syntax. It's much simpler now. Now you just have a table, and then you filter it, and you select some things, and then you filter it again. Then you join it, then you aggregate it, and you order it, and that's it. No nesting, right? It's just a sequence of steps. And yeah, so and another kind of advantage here is that with aggregations, you'll notice this pipe aggregate step, this pipe aggregate operator. This is now distinct from the select operator, right? So if we think about it, with ANSI SQL, your select clause will compute a projection, or if you start putting aggregate functions inside, now the behavior changes, right? Now it's an aggregation, and now there are different rules, right? Now every select item has to be an aggregate function or a grouping key. It's different. As soon as one or more aggregate functions appear in that select list, we've changed the nature of what it's doing, right? It's now an aggregation instead of a projection. And if you mess it up, if you put an expression in the select list that's not one of those two things, you get an error message like expression blah is neither grouped nor aggregated. This is invalid. And you're just kind of like, and you think, oh, okay. Yeah, there's another count star somewhere in their select list. So there's an aggregation. It's like, in contrast with pipe syntax, you can't do aggregations in the select list at all. You have to say pipe aggregate. And now every aggregate expression in the aggregate list has to be an aggregate function. You can't have any non-aggregate expressions in there. You can have your group by clause, right? So what this means is the regular pipe select is just always a projection. If you make a mistake, you put an aggregate function in there, it gives you a very simple error saying you can't do aggregate functions in pipe select, use pipe aggregate instead. It's like, oh, okay. And then kind of by the same token, if you are using pipe aggregate and you put a scalar expression that's not an aggregate function there, it'll say, this is an aggregation. You have to use pipe select for that, right? So it's kind of much clearer. You say, oh, I'm doing an aggregation or I'm doing a projection, and that's it. Cool. So yeah, if you want to get started with this stuff, it's very backwards compatible, right? So it's not like you have to commit to a wholesale migration. I'm going to move all my stuff over. It's going to be this big effort. It's not like that at all, right? Pipe syntax queries are table subqueries that can appear anywhere a table subquery can appear, right? So you can take, for example, that TPCH query, convert only the inner table subquery to pipe syntax and leave it there. And the rest of the query will still work. And this is valid, right? Or you can take an existing SQL query and then add pipe operators at the end, right? So the pipe operator can appear after any valid SQL query. We introduced from T as a way to start it, just kind of like a canonical way to start a pipe syntax query. But you can start adding these. You can add pipe where to filter after any query, and it just works, right? So you can just start adding this stuff. You don't have to. You can have a big extant SQL query collection and just start getting into it. So you don't have to. It's not an all or nothing thing. Cool. Okay, so that's pipe syntax. Next big SQL feature, SQL UDFs. We've been waiting for this, right? Idea is simple. You can now define UDFs whose body is a SQL expression instead of a bunch of Python or Scala, right? You can use named arguments with this. You can have default values, and you can return a table if you want. So what does this mean? It means you can just put reusable logic in SQL in these functions and just call them repeatedly. So you don't have to copy paste a bunch of stuff. You can also kind of deduplicate. If you have a lot of similar views, you can make a SQL UDTF that returns a table, just like the view, but the view can be parameterized by an argument or multiple arguments, right? So this lets you dedupe, refactor your logic, and kind of share it so you can reuse it more easily. And also the query execution performance of SQL UDFs is very fast, right? Because they're not interpreted at all. When you call these functions, Catalyst will just plan the expression in the SQL function at the call site into the query plan. And thereafter, it just integrates, right? So all the query optimization rules and Catalyst will run over it, just like they run over a regular query. And it'll run just like you type the equivalent query, right? So there's no interpreters at all. There's no step change. It's just operators and expressions, right? Cool. So here's an example. Say create function, roll dice is the name of this example. You can have 2 arguments. They have names, they have types. You can have a default value. You can have a comment, which is a good practice to kind of help future readers. For the arguments, you can have a comment for the function itself. And a return, you can have an optional returns clause for the output type. It's not pictured here. So if you omit this returns clause, it'll give you, it'll just infer the result type from the body, the function, and use that for convenience. And then there's the expression body. Right, so you can kind of call this with different arguments. Here we gave the arguments default so that you don't have to specify them in the call. If you don't provide the values for these arguments, it will use the defaults instead. Cool. So those are scalar SQL UDFs. You can always also do SQL table functions, right? So they can appear in the from clause and return a table. And you can use this to implement parameterized views, right? So here's an example of that. Create function, weekdays, take 2 arguments, returning a table of the schema, right? You can also just say returns table, and that'll just infer the result schema from the following query, right? Say return, select, query, and it'll give you the table relation output based on the input arguments. Right? So in this example, it does a lateral explode operation to do an unnesting, right? And referring to the input arguments. Right, so this is kind of an example of how to use it, right? You select columns out, the SQL TVF appears in the from clause, passing in some arguments. Yeah, so that's one way. You're using literals on the left side. You can also pass lateral references as arguments. So you can use lateral correlation. On the right side, we use this with the inline values list as just kind of a simpler example. But you can also do this with a table, right? You can say like from table T, lateral SQL function, passing a column reference to the table on the left side as an argument, which means for every row from that left side table, you're going to call the UDTF, the SQL UDTF once, give you an output relation, and the result will be a concatenation of all of those for every set of values from the left side, right? So you can do a lateral correlation. Cool. Yeah, so if you want to kind of introspect and query what do these functions look like, you can run a describe. It'll give you the names and types of the arguments. And you can use SQL named arguments to call them as well, right? So you can, kind of like Python, call the function. You can swap the arguments, provide them in out of order if you want. They can have defaults, right? So if you don't provide the value, the default will be used, right? So if you give, this is kind of nice for extensibility. If you want to add, like tweak behavior, you can add new arguments later with defaults. It won't break in existing call sites, but now new callers can like say named argument arrow value, right? Cool. Okay, so we'll briefly mention stored procedures. SPIP went in for this. So stored procedures let you build in functionality, and you can use the call command to call the procedure, passing some values in. It'll perform some operation with side effects, right? And then give you like a simple status result, right? So for this example, we can integrate external Apache Iceberg procedures into Spark and call it, passing the arguments like this, right? So it's just kind of nicely integrated. Makes it easy kind of to integrate stuff in and just use SQL. Cool. Okay, so next feature, this is a big one. So this is SQL scripting, right? So this is kind of extending SQL from just a query language or DML, DDL commands, right? One by one. Now you can write entire scripts and entire programs with just SQL, right? So if you've used like T-SQL or PSM before, this will seem familiar to you, right? So now you can do loops and like if else blocks. You can do for loops now in SQL. You can actually have exception handling, and you can use parameterized queries that execute immediate. So you can do very powerful things now. So this is PSM. This is a standard, right? So if you're used to SQL, PSM, and other kind of engines, it'll behave consistently. This is an initial example. You say begin, end, declare variable, while loop, and then inside you can do stuff like you can actually perform DML in here. So you can insert into the table something with side effects. You can create tables, you can select from them. So you can see, how powerful this can get. Right, so there's more kind of a sophisticated example here. You can query the information schema. You can look at metadata. You can set variables. You can do an execute immediate. To execute immediate takes the string and then runs it as a query. So you can like programmatically construct your logic and then fire it off. Yes, it's very powerful. If you have analysts who in your group that only want to use SQL and they don't want to use Python, some folks have mentioned that this is an option, right? So the PySpark is kind of very powerful. It's been in Spark. You can use Python for the procedural logic and SQL for the query logic and jump back and forth. And that's kind of been state-of-the-art thing in Spark for a long time. Now you can just do it in SQL if you prefer that, right? Cool. And then to finish it off, to wrap it up, talk about two new usability features that folks have kind of asked for a few times and make life a little bit easier for you. Cool. So the first one is PySpark UDF unified profiling. So if you're using PySpark UDFs and it's the age of AI and there's a lot of Python happening and it's like kind of popularity is going up, you might want to see what your stuff is doing. You're waiting for your Spark job and you're like, what's going on? And Python can be expensive depending on what you're importing and doing, right? So now you can actually profile your UDFs, right? And you can profile them with performance and memory, right? So if your stuff's taking a while to run, you can see where the time is going. And if you want to know what your memory usage is and you know how to set up your cluster, you can profile the memory as well. Right? You can show, dump, and clear the profile results like this, right? So here's an example, run a UDF, and you collect a performance profile and then look at it. And you get something like this, right? So this is where CPU is spending its time in the Python that you've dispatched to the cluster. Okay, and then for memory, it's kind of the same idea. You run a memory profile, and what you get is kind of a breakdown of where the memory is gone among the function calls in your program. Cool. And finally, nice usability feature, PySpark now supports plotting in built-in. So you can take any data frame and just do quick plots and look at the data, kind of visualize it, right? So how does it work? This is integrated with Plotly. So if you've used Plotly before, this will be familiar to you. Yeah, and the idea is basically like compute any data frame that you want, and you can run a plot on it, and you get the result, right? So these are the different plots available. There's bar charts, area plots, box plots, histograms, and pie charts, scatter plots, some really frequently used types of plotting, right? So here's a simple example. You take a data frame and you say df.plot.scatter. It's just built in, and you just say, oh, I want to see what this is. You say dot plot on it, create a scatter plot, and you get a graph, right? You can look at it and see what's going on. Right. So yeah, and for the pie charts, there's one of my favorites. This is really, really easy to use. You just create a quick pie chart to say, like, how big are the groups in this set, right? So it just takes a table of 2 columns. First column is like a category column with the strings, and the second column is a count. And you say dot plot dot pie, and it'll give you a pie chart where each slice of the pie is the subset of the total count of that category. And it's just pretty simple, right? So, right. And yeah, so that's the talk. To summarize up, to kind of wrap it up, Python is awesome. It's kind of become the #1 choice for data scientists recently. Tayubi Index kind of speaks for itself. You've seen it's been #1 for a while, and then there's this kind of jump in the last year or so, even more than just like a little bit. It's just like it's gone up a lot because of AI and kind of machine learning type of stuff. But it's also an awesome language, right? So yeah, so PySpark was born in 2013 in Spark 0.7, and it's grown a long way. So yeah, thanks a lot for contributing to it and using it. It's gotten over 330 million downloads PySpark last year. So it's definitely being used a lot. And yeah, over 210 countries over the last year. So it's definitely being used all over the world. And yeah, just wanted to say thank you for being part of the community and invite you to join. Download Spark and use it, and also feel free to join the developer community as well. Yeah, thanks a lot for your time.
Well, thank you, Daniel. Thank you very much for this very expansive explanation of Spark 4.0. As we said earlier, we couldn't cover everything, but there are going to be subsequent more deep dives on individual features. I have some questions that actually came in, so we might entertain a few more questions as we have a few more minutes left. I'll take the first one, and then Scott can pick up another one. We have people from all around the world. Ashik, let me see. We have a question from Martin who says, can we expect will the variant type also allow processing JSON with non-strict schema in arrays?
Yeah, that's a good question. Yeah, so the answer is yes, right? You can do this now, right? So the idea is you can ingest the JSON, and if it's valid JSON, then the ingest into variant will work, and then the arrays can have the fields in the JSON can have any values or types that show up, and they don't have to be the same from record to record, right? So you can have one record with one row with an array of integers, and then the next one has an array of strings, and so on. And this is valid, right? You can use, and then you can introspect into the contents with the built-in ways to introspect into variant types. And if you try to get the integers out of the array, it'll work for the first record, and it might fail dynamically for the second one because it doesn't have integers in the array, right? So it's kind of up to you. If your data set happens to have the same schema for the arrays, and you know that, then awesome, go for it, and you can query them out. But if you happen to know that it's not strict like that, then you can use variants for that as well.
Scott, do you want to pick one on SQL pipe?
Actually, there was one about will it be possible to register custom Python data sources to Hive or Unity catalog? I think that Daniel, maybe you want to answer that one, but I think it's a good one to discuss.
I don't actually know off the top of my head what the status is on that. I think Allison, she's the developer of this feature, so she'd kind of be the kind of source of truth on that. So yeah, right now you can register them like UDFs.
Right.
So that's kind of what works now. So
register at the session level essentially, and I think it's on the roadmap to register them in UC, but it's not there yet.
Cool.
I know that you can register Python classes, but I'm not sure whether you can actually register data sources. But that's a good question. We'll actually follow up on that one, Scott.
Yep.
There's one from Clint Hall who's asking, SQL pipe syntax is very cool. It seems a little more like a new language than any extension to SQL. Is it used in any SQL dialect besides Spark SQL at this time?
Yeah, it's a great question. It's kind of first thing that might pop in people's head, like this seems new. What's the deal with a standard, right? SQL has a standard. This is new. What's the deal with that, right? So kind of the direct answer to the question is it was kind of developed by Google, and it's available in BigQuery, Google BigQuery production, right? Exactly the same behavior. It's also Google's open source their SQL dialect, their SQL analyzer and parser, the Zeta SQL open source project on GitHub. So it's open source to there, so you can actually poke around and look at the exact grammar of the pipe operators and how they analyze. Although, having looked at it myself, it's actually a lot easier to just read the paper that they wrote than try to like poke around at the code. But it's there. Any project using Zeta SQL will support it. I think there's also there's an extension for DuckDB that you can use pipe SQL, although it's not default enabled. But I think it's so. And there's also just kind of a lot of buzz about it in the community. So I would say, my coworker Serge Relo, who's a SQL expert wizard, right? His view on this is kind of like, yeah, you should keep to the standard, but how do you think the standard was born, right? Like, how do you think these features came? Like, where do window functions come from? You have to innovate, right? So innovation will make SQL better and keep it strong. You have to balance. Don't make weird, non-standard, silly stuff that diverges from what everyone knows about already, but you also have to innovate, right? And this is kind of a way to do things that you don't need a lot of lateral correlation. You can just like kind of orthogonally compose the operations. And it's actually very kind of similar to Spark's philosophy the whole time with data frames and stuff. So yeah, that's kind of the philosophy behind it.
Scott, you want to pick one on the UDF and UDF in pipe syntax?
Oh yeah, the question was, is it possible to use UDF or UDTF in the pipe syntax queries? So like basically use the two features together.
Yeah, they're orthogonal, right? So if you can call a SQL UDF in a select clause with regular SQL, you can do it with pipe SQL.
And a
same
pipe
for Python or any UDFs. So they're just yeah. And for UDTFs, you can put it in the from clause.
They're composable.
Yeah.
Yeah, I like the whole idea about the SQL syntax extended to do all these different things. I think one of the questions that comes up is that when you're actually writing SQL scripting or you're writing SQL pipes, is the ACT syntax created different from, let's say, if you were doing the same thing in data frame? Are they equivalent or are they completely different?
Yeah, that's a fair question, right? So implementation wise, it's actually handled very, very early, right? So in the parser, specifically in this AST builder file, is where all of the processing of the pipe syntax clauses come from, get handled. And thereafter, it's just a catalyst plan. So it's even like before it's even analyzed, it becomes an unresolved query plan that's appears identical as if you just written equivalent SQL or data frames, right? For example, Spark Connect data frames, if you issue a bunch of operations, they're not eagerly analyzed with Spark Connect, right? So you just issue the whole sequence to the server. It'll analyze them into an unresolved plan. Or more specifically, the client will parse them into an unresolved plan, send that over the wire to the Spark cluster. And when it gets there, that unresolved plan before the analyzer runs looks the same as if you'd done the same logic with pipe SQL or just written regular ANSI SQL, right? So it's just no difference in behavior once you hit the analyzer and beyond.
And I think that answers a question that came up more recently from Dina, which is about like, will there be any performance difference between Spark SQL and Spark Pipe? And I think the answer is essentially, you just answered that. It's essentially no, because under the covers, it just gets, essentially it's equivalent to writing it in Spark as far as performance and query planning and execution goes.
Yeah, and the same applies for SQL UDFs, right, as well. It's just a plan. And this is something, if you use it for a bit, you kind of get used to this idea, but some folks get confused and they say like, oh, UDFs are slow. I don't know. I don't like this. All this stuff, it's not like interpreted by an engine and then like the data isn't like serialized around. It's just becomes a plan. So if we can do that, like if you can use your logic in this way, performance is good because the optimizer can do its job, right?
Another question that actually comes, depending on the improvements made to Python UDF, are we free to use it with our eyes closed? Or is it best always to minimize its use in your code?
Yeah, so this is the question. It's like the same kind of line of thinking I was just mentioning, right?
Right.
So the answer is, I wouldn't suggest to minimize it. I would definitely use Python, but in contrast to the SQL logic I was talking about, it is not just inlined into the query plan. It actually runs an interpreter, takes the input arguments and like serialize them, hopefully to Apache Arrow, if you turn that on, right? Runs it to the interpreter. So this does cost something, but it's really up to you. If your logic, I would say if your logic is simple, try to use SQL, or try to use a SQL UDF. It'll be easier to understand and also fast. But if you want to use powerful stuff, or if you just prefer Python, go ahead and use Python and then run the profilers on it. If you're wondering like, why is it taking this amount of time, or why is it taking this much memory, right? So I would personally, like, there's different philosophies on this. Like some people would say, just go big on Python and just do it. And then it is what it is. And certainly if you're writing ETL that just runs overnight and, it doesn't really matter if it takes 1 or 2 hours, then, it just doesn't matter. But I'd say a balance is probably the healthiest way. Like use SQL where you can, and if it's simple, and then if you want to do more elaborate stuff using imports, then Python can make sense, and use the profilers if you want to dig into what's going on, right?
I think, Scott, we can actually take 2 more. I'll take one, and then you take the last one. Someone from LinkedIn users asking, if we migrate to Spark 4.0, does this impact the existing SQL? So if I've written all this SQL code, and if I'm migrating to 4.0, does it impact my existing code?
I don't think so. The only exception I can think of is ANSI mode is on by default in Spark 4. So if you don't change any settings and you're not using legacy Hive SQL semantics before, behavior might change, but you can just toggle it off if you really want to, or take a personal challenge and migrate to ANSI mode, which is better. But migrations do take work, right? So you have an option. But other than that, the SQL is backwards compatible. So as we develop it should be, right? So as we develop the API, it shouldn't break any existing queries at all. If it does, that's probably a bug, and we should address the bug. But in general, that shouldn't have any impact on SQL.
Scott, you want to pick the last one?
Yeah, sure. Are there any plans to enhance Apache Spark with support for native user-defined functions written in C++ or Rust?
Oh, that's the big one. It's a big question. I don't think so as of now. Kind of Spark is very, JVM focused, and with the exception of obviously of PySpark, Python, but the JVM focus is kind of, I think, contributed to its success as an open source project to an extent, right? You get the built-in Java libraries, and there's kind of an understanding consistency for different users. And it's also very tolerant on failures. If you reference a null pointer, you get an exception rather than a crash, and right, that's Java for you, right? So that's kind of the focus, and it's a good robust approach for really long running jobs, which Spark is really strong at, right? Like if you want ETL, you don't want it to crash 2 hours into the job, actually, right? And especially you don't want your driver to crash or your cluster to crash if it's running a bunch of different jobs and one of them misbehaves. You don't want that at all. The misbehaving one can throw an exception, deal with it later, right? So that's kind of the philosophy on that. So yeah.
Cool. Thanks, Daniel.
Cool.
Well, thanks a lot. I think on that note, we are almost over time, but the feeling I got from this one that SQL syntax has really gone above and beyond. And those people who will love SQL are beginning to say, "Hey, I don't need to use Python now. I can do everything in SQL." So I think a lot of data analysts are really going to be happy that they can actually use the power of Spark, using all this SQL scripting and writing all this user-defined functions using SQL. But anyway, there are lots of questions over here that we couldn't answer, but we'll try to reply to you on LinkedIn and on YouTube after the fact. We had a global audience. We had people from North America, from South America, from Europe, across the Pacific, in India and Japan as well. So I want to thank the entire global community to joining us. I want to thank Scott for being part of the conversation today. And Danielle, thanks a lot for sharing all these great things with the community. And we look forward to actually having more sessions on 4.0 in the coming weeks. So thank you again.